Okay, pair of linear equations in two variables. We have seen in our last video that two lines, when they intersect at this point, we have a unique solution. Unique solution, let me put it here, unique solution, right? We have one solution for x and one for y. We have one unique solution for these two intersecting lines. Okay, that is why it is called, firstly it is called intersecting. Okay, it is intersecting at one point. See, we cannot have two lines intersecting at many points. Then these are not lines. It can intersect only at one point. Okay, now unless of course it is parallel. Okay, that we will see here. The third one is because it has a solution, it is called a consistent pair of equations. Consistent, there is a solution. Now let us see this one. Okay, there is one line which is like this, the other line is this, they are parallel, it never intersects. It is parallel, it goes from here to Delhi and from here to Delhi, both, but it never meets. So this is called non-intersecting, and it is called inconsistent because it does not have a solution. Consistent, yeah. And the third one is it has no solutions. Okay, we know how to make lines like this, and we know how to draw a graph and draw the lines like this. And the third one, suppose you have one which is like this, and the second line also is on top of this. Both lines are on top of this. Okay, you can have first line is x plus y is equal to 4, and the second is also x plus y is equal to 4. So both will be falling on this, right? So they are both falling on a same line. So it intersects at many points. So it has a solution, okay, but infinite solutions, many solutions. Okay, it is intersecting at many places and is consistent because it has a solution. Okay, you need to know all these three. Okay, we have seen that by drawing these graphs we can come to know whether it is intersecting, whether it has a solution, a unique solution, or it has infinite solution, or it does not have a solution, but for which we have to draw the graph. Now without drawing the graph we can also do it. Let us see. We know that the standard form of a linear equation in two variables is ax plus by plus c is equal to 0. Okay, I am standard form here. But suppose there is a pair of linear equations. This is one. This is equation 1. We have another equation of ax plus by plus c is equal to 0. This is the second equation. Now, how do we differentiate? Because both of them can have a different coefficient. So what we do is we put a1, a2, b1, b2, c1, c2. Okay, we can add something like this. Okay, let us see this table which is given in your book. We are given a pair of lines x minus 2y is equal to 0, 3x plus 4y is minus 20 is equal to 0. Let us see if a1 upon a2. Okay, A1 is this. This is 1 upon 3. Okay, B1 upon B2 minus 2 upon 4. Or if you cut this, it will become minus 1 upon 2. Okay, this is the final answer. This is the final answer here. And C1 upon C2. C1 is 0. 0 upon 20 minus 20, which is equal to 0. So let us compare. What will happen is that A1 upon A2 is not equal to B1 upon B2. Okay, just remember this. If A1 upon A2 is not equal to B1 upon B2, it is equal? No. 1 upon 3 is not equal to minus 1 upon 2. Then you will have a unique solution. Okay, or it will be intersecting, or you can call it, it will be consistent. Okay, next one, 2x plus 3y. So what is A1 upon A2? 2 upon 4, which can be also, if you cut, it will be 1 upon 2. Okay, this is 3 upon 6. If you cut, it becomes 1 upon 2. And minus 9 upon minus 18, which is also equal to 1 upon 2. So if you have A1 upon A2 is equal to B1 upon B2, B2 is equal to C1 upon C2, then it is parallel. Okay, so it is not, it has infinite solutions. Okay, infinite solutions. There are many solutions because they are, this one line is above the other line. So, and here what will happen is it will become like this. It will have a unique solution. And let's take this one. Okay, x plus 2y. So A1 upon A2 is 1 upon 2. A2 upon B1 upon B2 is 2 upon 4, which is also equal to 1 upon 2. Good. A1 upon A2 is equal to B1 upon B2. And let us say C1 upon C2. C1 is minus 4 upon minus 12, which is equal to 1 upon 3. So if A1 upon A2 is not equal to C1 upon C2, okay, or B1 upon B2 is not equal to C1 upon C2, you can also say that A1 upon A2 is equal to B1 upon B2 and is not equal to C1 upon C2. Or we can write that, that will be a better solution. Okay, you can write that. A1 upon A2 is equal to B1 upon B2 is not equal to C1 upon C2. See, here it is equal to, here it is not equal to. The same, but here it is not equal to. Then you have no solution. Or it is inconsistent. This is consistent, this is consistent, this is inconsistent. Okay, this is from your from this, it will be easy for you to solve exercise 3.3, where you are asked, especially sum number 2 and 3. For graphical solutions, you will not be asked in your examination. So we will concentrate only on the algebraic solutions, solutions without drawing the graph. Okay.